West Point Bridge Designer allows us to use standard truss templates when we're designing and simulating bridge construction. There are three standard trusses that are used universally in engineering: the Hal Truss, the Pratt Truss, and the Warren Truss. All three trusses have both a through configuration where the deck is on top, or the deck is on the bottom of the bridge, and the vehicle is driving through the truss itself. Or there's the deck truss where the roadway loads on top of the truss and the truss lies below, the structural elements are below the road. So what are the differences between the Hal, the Pratt, and the Warren? I've put together a page for you that you can reference that has this three trusses illustrated for you. I've taken information from engineeringcivil.com from a question forum there, and put together just a series of basic answers for you. So the Warren truss is a set of equilateral triangles, and that Warren truss configuration more or less equally distributes tension and compression across the members depending how it is loaded. It is more of a dynamic design than the Hal and the Pratt designs. If a Warren truss is used in a longer span, you may see these equilateral triangles bisected with a vertical member coming down between the two of them. And that allows us to make for a longer span with our truss. The Pratt truss is characterized by diagonals, having diagonals that slant towards the center of the bridge. And because of that, the diagonal members are under tension and the vertical members are under compression. And so select materials that lend themselves well to each of those two forces. Some materials perform better under tension than they do under compression. The Hal truss is the exact opposite. The diagonal members are slanting away from the middle. Now, both of these are in through truss configurations where the abutments are here on the bottom of the truss design. So our diagonals are slanting away in the Hal truss, and therefore it's an exact opposite with tension and compression. Our compression is on our diagonal forces being compressed back here to the abutments, the supportive abutments, and there is tension on the vertical pieces up and down in the Hal. So if you can keep these principles in mind as you're designing and working both in the West Point Bridge Challenge that we have, as well as in putting together and building a bridge to test, then you'll find your results are far better. Good luck as you tackle the structural engineering challenge of bridge design.